Okay, now we'll go for retention. Now we'll go for retention time calculation. Retention time calculation. Okay, so in previous case, in two phase, three phase, if you have seen high pressure case, so in that case, gas phase, gas based calculation, liquid based calculation you have done, like gas capacity based, liquid capacity. But in this case, we are not considering gas part, we are considering the liquid part, how water particle is getting separated. Okay, because you are treating oil water emulsion and you are trying to get 0.5% BSW around liquid oil, not with solid or gas. Okay. So that is why we are not including the gas capacity equation here, only liquid part you are calculating, liquid separated from liquid, water particles separated from oil, okay, not vice versa also. Okay. Now for horizontal vessel, d square LEFF equals QO TRO 1.05. Okay, this formula we try to derive. So T again, T equals volume divided by Q. Okay, assumes 75% effective length is useful. Okay, they are assuming 75% effective length is useful for separation. Okay. So in that case, volume equals 0.75, we are multiplying, and what is the area? Pi by 4 d square into L effective length. Okay. So this area is pi by 4, this area into this effective length. Okay. So total volume of fluid we are calculating. So this is area, this into L effective length. Okay. D again I am writing capital, that means unit is feet. Okay. So if I want to convert into inch, then it will be like 0.75 pi d square L effective length divided by 4 into 144. Okay. And Q formula already you know, 6.49 into 10 power minus 5 Q oil. This is BPD, BPD, this is cubic feet per second. Okay. So if we equate, so volume divided by flow rate, if you make, then it will come like this: d square LE effective length equals 0.0159 QOT, and TR in minute, TRO in minute, this is second, this T is second. Okay. So TR in minute, so equation will be like this: T equals 60 TRO, therefore d square LEFF equals QO TRO 1.05. Okay. So this is your retention time calculation formula: d square into LEFF, QO, not only Q, otherwise unit will be a problem. I am using Q, unit is cubic feet per second, QO barrel per day, BPD. Okay. This is for horizontal separator. Okay. Now we will go for vertical separators. You finish this one then. Okay. For vertical separator, retention time. Retention time. Okay. So vertical separator formula is there: d square H TRO QO 0.12. So this is the formula, final formula. But how to derive this one? For derivation, you have to remember again, T equals V volume divided by flow rate. Okay. So volume equals I have to draw one vertical separator. This is height for actually oil pad height. So their coalescence is happening. Okay, coalescence. Okay. Now volume equals pi d square by 4 into h by 12. Okay, so this area, okay, and this height. So total volume is becoming now 4.55 into 10 power minus 4 d square h. So capital D I converted into feet. So okay, is yeah. So that way we got this formula, volume values. Now Q in B QO in BPD, Q feet cube per second. So Q equals 6.49 into 10 power 10 power minus 5 QO. Okay, so this formula we already know. Now therefore T equals, T means volume per flow rate, you can see here actually. So volume I got 4.55 10 power minus 4 d square h divided by flow rate we got 6.49 into 10 power minus 5 QO. So if we equate this one, so T we get 7 d square h QO. Okay, now TR in minute, TR in minute, TRO you can say. So this will be giving d square h equals TRO QO 0.12. Okay, so you got the formula for retention time, okay, for vertical separator. So you should not mix up horizontal vertical, so you should remember that. Okay, so if you know derivation procedure, actually remembering will be easier. If you want to remember the final equation, then sometime you can get confused, okay, whether it will be for vertical or horizontal. Okay, and for gun barrel, okay, for gun barrel this is vertical. For if we go for gun barrel, the formula will be modified as d square h equals f came up, now TRO QO 0.12, same formula, only f came up. Okay, short circuit factor, but short circuit factor can be applicable for your vertical heater treater also. So already we have seen. So droplet size, okay, so normally 500 micrometer or micron size you can take. There are some formula, so 10 to 30 minute retention time they are assuming, 10 to 30 minute for initial assumption retention time, okay. So for initial assumption, previously we said that 500 micron water droplet size we consider, okay. But there are some formula, the Throw and Morris Morris 1994, they develop using 1% water cut, okay. So for 1% water cut, the formula they derive like this, dm 1% equals 200 mu power 0.25, okay, for mu less than HCP 80 CP, okay. For dm diameter of water droplet, this is dia of water droplet to be settled from oil to achieve 1% water cut. Okay, micron. Okay, mu O already you know, oil viscosity. Okay, using the same procedure, the following correlation for droplet size was developed for electrostatic teeter. For electrostatic teeter, dm 1% equals 170 mu 0.4 and the range is 3 cp to 80. Okay, this within this range, this equation should be valid. Okay, and how to implement this formula we'll see when we'll be solving problem, we'll see. Okay, so one more formula we have, dm by dm 1% equals water cut power 0.33. So what is this formula? Okay, so we can make box for this formula, this formula. Okay, this formula. So dm is the diameter of water droplet, dia of water droplet, to be settled from oil to achieve given water cut. To achieve given water cut, or WC. Okay, and WC is percentage. What a percent? 1%, 2%, something. Okay, so you want to achieve, so your diameter size will be like this, the formula. Okay, 0.33 power 0.33. Okay, so it should be 0.33. Okay. Done. Okay. So for conventional treater, they have given on chart or figure. So treating temperature for treating, and flow rate, BPD or BOPD. Okay, so the like 20 degree API, 25. So this way increasing, 25 degree API, this is 35 degree API. Okay, treating temperature, and temperature like 0, 50, 100, 250, up to 250 they have given, and flow rate range also they have given 160, equally divided actually, not logarithmic but any other scale, it will be equally 160, equally divided. This is for conventional. NA. Okay, and another they have given for electrostatic teacher, same thing, temperature and flow rate. The range is becoming lower. Okay, 20, 25. Okay, 35 API. So in this case, flow rate is higher. For this is electrostatic treater. So in this case, flow rate is actually higher. Okay, for same temperature, you are getting more flow rate. So your productivity or separation rate is higher. So before we solve one problem, okay, before we solve one problem, we have again the heat transfer calculation, because I think several times we have done. Again, one more time, just recapping purpose. Heat transfer, because we have to size the whole separator. So heat transfer formula, again recapping. So Q equals mCT. You already have gone through this formula, okay. And mass flow rate, if you have flow rate, you know, then mass flow rate you can calculate like this. Q, this is BPD or small BPD, mass flow rate pound per hour, okay. Then BPD you can convert like this, BPD divided by day into day hour, 5.61 cubic feet divided by barrel into 62.4 gamma cubic feet by pound lb per hour, okay. So this will be giving m equals 15 gamma q lb per hour, okay. So if you are given q in BPD, then you can convert pound, okay, pound per hour. So normally amount of water is given as percentage of oil volume, okay. So Q water will be percentage of oil volume. So this is oil volume percentage, okay, how much water is there. So QO equals 15 gamma O CO QO, because this unit conversion, that's why this 15 term is coming, del T. Q water, if I say the 15 gamma water, C water, Q oil, then W will come, okay, and del T, same del T, okay. Then how much total heat they are taking, how much heat is getting lost. So as it is previously, same but different way they have derived, okay. Let's say L% energy lost, and how this energy getting lost, because of radiation, convection, conduction, because of this way some energy will get lost, you cannot recover that one. So that heat will not go to your go to heat your oil or water, okay. So that heat you cannot recover, energy you are giving from your burner, but that heat is not reaching to heat your fluid, okay. So Q oil plus Q water plus Q loss equals total, okay. This is the basic formula I am saying, something is lost, energy lost, okay. Previously also this formula is given actually. So finally this formula become like this, Q equals 1 by 1 minus L, percentage of energy lost, okay, 15 QO delta T gamma O CO plus W gamma W CW. This is BTU per hour, okay. This is the formula for heat transfer calculation. So anyway, whatever formula you can use, basic formula is Q equals MST, you have to remember, then you have to convert units, then done, okay. Mass, specific heat and temperature difference, the heat, so you are getting heat transfer rate, right. Now you convert units, if I am not giving directly your barrel cubic feet or degree Fahrenheit, let's say instead of degree Fahrenheit I will give Rankine temperature or centigrade temperature, I can mix up in your exam. So if I am giving centigrade, you have to convert into Fahrenheit, okay. If you do not convert, then it will not match, okay. So those unit conversion you must remember, okay, because field unit, SI unit and so many units are there, you are playing with unit actually. If you do one mistake anywhere in converting unit, then you are gone, you will not get marks.